Hello, everybody. How's it going? I'm seeing some familiar names in the chat. Now I can see that you're here. Hopefully everyone's doing well. Um, Again, just if you haven't already, remember to check in to the link that I just sent in the chat. That is very important. We use that to track who's coming, and you also get swag. So just remember to check in if you have not already. All right. So, as you all probably know, today we're going to be going over like running AI models in the cloud and how all of that is going to work. So it's going to be great. It's going to be a fun time. We're just going to be getting started with sort of like a quick, almost like a presentation or like a PowerPoint, very quick overview and introduction to like what AI is like at first, right? We all know we've heard of it a lot, but what exactly is AI? And then the different types of AI models that you can probably run on either locally or on the cloud, different AI models that exist, and then what cloud computing is and how sort of that correlates to AI as well, and why you might want to run AI models in the cloud. And then we're going to move on to sort of just different cloud service providers, the different options that you have when you're trying to deploy like an AI model to the cloud, and the different model options that you have. And then we're actually going to go and walk through an example. So it's going to be a fun time, and it is going to be a lot more interactive. So I would appreciate it if you all are really active in the chat. All right. Okay. Sounds good. So um, we'll get started then with actually what is AI. So you all uh, you all probably already have like a good idea of it. So you can just let me know in the chat, like what do you think AI is, or what's sort of the textbook or Google definition of it? You can search it up. You have the internet at your disposal. There's no pressure. You don't need to know this off the top of your head. We're all here to learn, so we're all learning together. So what is AI? And y'all can type this up, copy paste it, chat GPT it. It's not too important. Okay, well, Malik just got a full wall of text. Let's see. Artificial intelligence, in its broadest sense, is intelligence exhibited by machines, particularly computer systems. It is a field of research in computer science that develops and studies methods and software. And it just keeps going. And I think the text actually cut off. But yes, that is actually correct, right? AI is basically the ability for computer systems to be able to perform the tasks that we humans are able to do, right? So tasks that normally would require human levels of intelligence, that's something that AI helps computer systems actually perform. And that can be in like a bunch of different ways, right? So um, one of those ways is like visual perception. And visual perception is sort of just like seeing. So y'all can like put in examples of what sort of seeing would look like in the chat. So what's an example of like an AI system being able to see something? Okay, yeah, RenCap 12 said Tesla detecting people. So yeah, image recognition for cars or for self-driving cars. And then we also have Malik saying object detection. That's exactly right. And then there's other examples as well, right? There's a bunch of examples. For another one might be facial recognition. Facial recognition is also huge as well. So that's also an interesting one. All right. And then there are other types of, or another task that might actually also require human levels of intelligence is sort of speech recognition, right? We all know how to speak to other humans, but previously computers weren't very good at actually being able to speak to other people or learning from other people. So speech recognition is a huge one. And I mean, you all obviously know the example, like the classic example for this is like ChatGPT, Gemini slash Bard, or all those other LLMs. But what are some other like lesser known maybe examples of sort of speech recognition in um, or that uses AI? So one example might be sort of a speech to text app, right? Jarvis, yeah. One example might be a speech to text app where you say something to like your phone or you dictate something and it just completely writes it out. That's one good example. Another one might be like a customer service bot, right? Let's say you want help with something, you call up like a customer service line and then a bot is the one that's answering your call. Usually that's not a fun time, right? I don't like being on the phone with a bot, especially when I'm calling customer service. I usually want to talk to a human. So that might be an example of when AI is actually not appreciated that much, right? I don't appreciate it being in that specific situation. I'd much rather talk to a human and get my issue resolved quicker. But the whole point of AI is to get hopefully better and better and better over time. So a customer service bot or a voice assistant like Siri and like Google, I forget what Google's is called. I think it's just called Google Assistant. Those are also other examples of speech recognition. And yeah, in the chat, I see Aditi. Thank you so much. Yes, I'm glad that my video was able to help you out with video deployment. So for context, I had a video yesterday as well, which was just deploying your very first web app, and that was a great session. Hopefully it helped everybody, and it looks like it did help Aditi out. So I appreciate that, and Malik. And there's another comment that we are covering the topic of last Global Hack Week. That is absolutely correct, actually. Last Global Hack Week, the topic was AI. This is sort of just like a really quick overview of the like fundamentals of AI, just so that you all have an idea of like, okay, this is sort of what AI is, this is what cloud is, and these are where the two combine. Because if you don't have a really good understanding of what AI is, but you do understand what the cloud is, then you might not be as confident on where sort of the line is drawn between the two. What's the difference, right? For the most part, these are just buzzwords that are being thrown out in the industry. So I'm trying to really clarify what the difference is between the AI and between the cloud. So we're just going into sort of a deep dive for what AI is first, and then we're going to be going into the cloud section later on. All right. So yeah, speech recognition, and another one is sort of just decision making, right? Human beings make decisions all the time. Um, we have to decide anything from like, okay, what food am I gonna be, or what am I having for lunch, or where do I feel like, or what time do I go to the gym, things like that. So that's another way humans make decisions, and computers aren't really good at making decisions. So AI helps power these computers to make decisions. And an example of that could be, y'all can give me some examples in the chat actually. That way it is a little bit more interactive. Aditi said AI's definition is really fun, but when you're actually studying that as a subject, it is a tough one. That is absolutely right, actually. I'm doing my master's in AI, actually, believe it or not. So it is, yeah, it's a lot of math in the back end. Um, so Aditi also mentioned the neural networks. I feel like, yes, the neural networks are definitely one of the most painful parts, especially when you have to figure out what a neural network is doing by hand and then calculate back propagation and everything of that sort. It does get a little complicated and messy. A lot of math in there, but it's fun. It's still really interesting to see how all these systems work. So going back to decision making, another way that computers can make decisions, or some fields where they can make decisions in, are sort of stock tradings, right? So you have a lot of these big companies that actually rely very heavily on AI to trade stocks for them, a bunch of bots that are trading stocks at once, different trading algorithms, and these actually can be very lucrative. If you have a good algorithm, you can make a lot of money, like a lot of money. by just trading stocks and relying on that algorithm. So uh, if you ever want to make a lot of money, that's sort of the field to go into. A lot of AI there, a lot of potential. So that's one situation in which decision making is really big. The other one might be recommendation engines, right? So you might have like a Spotify or a Netflix subscription, and when Netflix says, "Hey, you just watched these different movies, you might also like this movie," then that's an example of Netflix's recommendation engine actually coming into play right there. So that's also something else that AI is able to do very, very well. So again, we mentioned neural networks earlier, and that is actually a type of AI model. And with AI models, it's really important to know that like AI and machine learning, we usually use them sort of interchangeably, but they're not actually interchangeable. Machine learning is a subset of AI. So all machine learning is AI, but not all AI is machine learning. It's sort of like all squares are rectangles, but not all rectangles are squares. Similar to that, I think that might help drawing the connection between the two. So AI is a slightly more broad version of machine learning, and machine learning is more specific. So machine learning just learns from data to make predictions, whereas AI also encompasses sort of neural networks, which at a higher level would be deep learning. And deep learning just uses a bunch of different layers of these neural networks for much more complicated tasks. Am I making sense so far? Going too fast, too slow? And I see someone in the comment, Malik, shouted out Three Blue, One Brown. They're actually an amazing resource, very good visualizations for everything. He has an amazing YouTube channel, and yeah, if I see Malik just typed that up. He has an amazing YouTube channel that has really great visualizations to actually see what different machine learning algorithms are doing in the background and sort of how neural networks work. And I know he has one really good and very popular video actually of this of how a neural network works, and it's sort of in identifying numbers. So this is actually a really interesting example of how neural networks work. We can actually go into that where let's say you have a bunch of handwriting, right? You have the numbers from 1 through 9. These are all digits, but how does a computer actually recognize that a 1 is a 1 and not a 9? Or how like a sloppily written 7 is different from a 2? So it's definitely a really interesting video. So yeah, shout out to Malik for actually um, bringing that up. That is actually a really great resource for sure, and I highly recommend you all check that out as well after the stream. So that's sort of like the big, really quick and dirty introduction to AI. You all can, if you want to learn a lot more about this, we have a lot of streams from our last Global Hack Weeks. And again, I just gave another resource as well. And Malik gave another resource. Three Blue, One Brown, great resource as well. So you can learn more about it there. Now, sort of to pivot to cloud computing. So, what is cloud computing? And I guess y'all can copy paste this too, but let's limit the wall of text that we're going to be seeing. So, cloud computing is actually just like the basically delivering compute power. So that could be either storage, it could be processing power in the form of CPUs or GPUs, and that's sort of just giving that to you over the internet. So yeah, Aditi said it is basically a virtual CPU. That is absolutely correct. You can use it as a virtual CPU, virtual GPU as well for cloud computing, and then cloud in general also includes like storage, for example. So you can have as much space, but not at your place. Yeah, that rhymes too. Yeah, basically there is still like that is still being stored somewhere in some data center, but it's not being stored locally where you're at. So it's still somewhere, right? It's not just like actually in the cloud and up in the air like it might sound like, but it's being stored sort of off premises or off wherever you are, off site. And yeah, that's exactly what a DT means, but not at your place. It's being stored at a different site, which is usually a huge data center owned by either Google, Microsoft, or Amazon. But we don't need to get into that. So cloud computing is usually better than actually, if you have like a lot of data, it is better in general, just because it's a lot more flexible, right? You can decide to move all your data from one cloud provider to another. You can it's very flexible in the way you're able to use it, what you're able to do with it, and very scalable as well. Let's say you're like trying to build a business, and we actually sort of touched on this yesterday as well. You want to build a business, and if it scales up like a whole bunch overnight, then if you have like on-prem storage or you're running all your stuff locally, on local hardware, then it's a lot more difficult to scale. You need to make an order to buy a bunch of more units of like just storage and compute and all of that, and it's a complete headache. Your website is down for a lot of people. Instead of having to worry about all that, you can, let's say you have your all your stuff on the cloud, and because it's on the cloud, it can expand as much as it needs to in the time that you need, and then you don't have a bunch of unused storage space that's going to waste either, right? So let's say you have like a product, right? You have a business. You went on the show called Shark Tank where you pitched, your idea, and it went live. A bunch of people saw that video and they bought all your, or they wanted to buy your product. Now your website is now having to handle a lot more traffic for this small period of time. And if all your servers go down, or you're running out of storage, or you're running out of space, then you're going to be losing out on a lot of business. So instead of that, what a lot of people do is they just rely on cloud, then they can expand or contract the amount of space they're using as needed, so they don't have a lot of either wasted space, right? Like free space that's being wasted, or they're not running out of space. So very useful in terms of that. And it is also very cost efficient. So I see actually uh, in the chat, there are some comments about the cost. So Malik said it's not free, which no, unfortunately, the cloud is usually not. They might have like a generous free tier. I know some companies do, but it is really not free in general. Yeah, but still a lot more cost efficient than buying like a huge server. And we'll actually look into that later on. So I'm going to be comparing some prices for like getting an on-prem sort of machine versus uh, actually being able to rent out sort of like a GPU or a CPU on the cloud. So it's going to be interesting. So I want you all to think on this. So why would we want to use AI in the cloud? What are the benefits for that, given everything that I just mentioned? Sort of running AI models on the cloud. Abhinav, I'm not too sure what you mean by this, but that's hilarious. Um, so Malik also said chatbot. That is one reason to use AI on the cloud. That's more an example of being able to use AI on the cloud. You can have a chatbot that runs on the cloud, but let's see. Aditi said to automate all of our tasks, saving many clicks. That could be one reason. It wouldn't be as much automation. That's more the tools that the cloud service provider is using. So for example, if you're using like AWS, they have a lot of automation tools you can use, which would save you clicks instead of you having to actually host everything locally. So to an extent, yes, actually, that is correct. And then Himan Shubalani said, because local hardware is expensive and AI needs expensive hardware. That is actually very correct and right on the dot, right? Local hardware is very, very expensive. And you can actually do like a quick Google search for what like an A100 GPU might cost if you wanted to purchase one yourself. And you can see how much that costs. And AI definitely does need expensive hardware, but it doesn't need expensive hardware all the time, right? It's usually just during the training phase when the AI is using up like the full capacity of that expensive hardware. And once the training is done, then it shrinks a lot more. Like it's sort of you have a fully pre-built model now, and you don't really need to do anything with the hardware now. So you just bought all this expensive hardware that you're running locally, and now you have nothing to do with it until you develop your next model, and then you want to train that on there. But at that point, your hardware might be too weak for that model that you want to train, right? Because you want it to be trained on a lot more parameters, which takes up a lot more compute. So yeah, that is actually definitely on the dot. And then we have some other responses. Execute tasks without using our resources, yes. Without using our own local resources. Scraping info for websites, that's another example of what you could use AI for. That's not really AI, that would be more just like web scraping. So you need a good internet connection for this one, for sure. But yes, that is actually why NVIDIA stocks went so far up, right? Because AI is, and let me just put the last comment of him on there. He said, because local hardware is expensive and AI needs expensive hardware. Now, because local hardware is very expensive, NVIDIA stocks actually went way up, like due to that fact, right? They were going to be selling a lot more hardware units to all these big companies that incorporate the NVIDIA GPUs and then sell them to other companies. So NVIDIA doesn't necessarily sell it directly to like AWS or Amazon or Google or Microsoft for Azure. They sell the GPUs to companies like Dell or companies like HP, and these companies create these like storage solutions that have a bunch of like sort of entire racks of these GPUs and a bunch of CPUs, and they do all the configuration, and then these sort of middlemen are the ones that sell it. And then we see Malik also has a few more examples for schedule and image search. So um, that's really the first big part of the sort of presentation, is just going over AI, and we have a pretty quick introduction to what the cloud is. So next, we're actually going to be going into deploying an AI model to the cloud, and that'll sort of be the second part of it. So again, usually the workflow for any AI model is like you need to obviously have good data and prepare that data, prepare it well, make sure everything works. You need to have a model that you actually train and then deploy the model and validate the model. In our case, we're going to be deploying an AI model to the cloud, but we're not actually going to be doing all of like the full workflow. We're going to be using a lot of pre-existing or pre-built tools just to make it easier on ourselves. So actually what I have is I have like a Google Colab instance open. And if you haven't heard of Google Colab, it's actually a really good tool for just running AI models and essentially in the cloud, because that is the cloud. You're not using any of your own local compute power, you're using all of Google's compute power. And they have like a free tier, which is pretty generous. They let you run a lot of stuff on it. And they have like a paid tier as well, but their paid tier is kind of expensive. So I actually opted in for a different company's version of this AI tool. So in sort of the second part, I'm going to be taking like a quick water break. And then for the second part, what we're going to be doing is we're going to actually code up a quick sort of stable diffusion algorithm. We're just going to be generating images, and then we're going to see how quickly we're able to generate those on like Google Colab or locally versus if we were actually running that on a much more powerful GPU, and sort of just the benefits of being able to run something on the GPU or on the cloud. Any questions on that so far? All right, if not, then we'll take like a 5-minute break, and then we'll come back and start working on our bot, or not our chat bot. I was reading the chat. We'll start working on our AI model that we can run on the cloud. All right. So we'll take 5 minutes and be right back. All right, everyone. Hopefully you all grabbed some water and got a couple minutes to rest. Now we're going to get into like really the meat of what this whole thing is about, which is actually deploying an AI model in the cloud. All right. So to start off, if you all can open Google Colab, which let's Colab. I believe that's colab.research.google.com. colab.research.google.com. Hello, way. That's awesome. We got way over here. Is another MLHer. So let's see. All right. So right here, just Google Colab, and you can just open up a new notebook, and we're just going to be coding up a very quick and dirty sort of stable diffusion example. And I have the code over here, so I'm sort of cheating, but you all don't. So we're gonna be writing this together, and what we're actually gonna be doing is just testing, seeing how fast it runs on, let's say, Google Colab, which is a slower VM, and then on a hardware like an accelerated GPU, which I actually rented out from the cloud, and I'll be showing you all how that sort of works. It's gonna be great. All right, so let me share my screen. Stable diffusion. Okay, there we go. So you all should be able to see that now. And is everyone good? Everyone got sort of Google Colab opened up? Okay, excellent. So first and foremost, obviously, is we need to install all the packages that we require, right? And that is going to be, we're gonna have like a good number of packages. Again, we're using a lot of sort of pre-built tools over here at our disposal just so that we don't have to write a whole lot. So we're gonna make this quick. So obviously it's pip install, and then we have, you can also upgrade anything that isn't already upgraded, diffusers, and then transformers, and then accelerate. And this is just sort of to make everything run faster. It works. Media pi for the actual pictures, and PEFT. And hopefully that runs without any issues. And if you all don't want all this output, you can also add like a quiet flag. So just dash dash quiet, and that actually probably would have been helpful earlier. So this will sort of install everything, but not give you all that output to worry about. All right, and then we're going to want to import a bunch of stuff, right? So now we are going to be first import MediaPy, and this is for our images. Import. We are going to need torch. Are we going to need diffusers? We can get to that later. So import MediaPy, import torch, import random. That's not how you spell import. And import. You don't have to import sys right now. This is more just if you want to actually save anything on your local device or onto here, fully up to you. And then from diffusers, let's import not stable diffusion pipeline, just diffusion pipeline. And TD. And then from Hugging Face Hub, we're going to want to import. Don't know why it imported a bunch of other stuff. Hugging Face Hub download. And this is because we're going to be using a pre-made model that's already on Hugging Face. So this is just us basically getting one of those. So we're going to first need to actually code up the number of inference steps. And let me see if everyone's following real quick. So the install command is right here. Pip install. Actually, yeah, I think it might be easy if I just copy paste everything to here. And then I can also publish this later on. So this will be accessible to everybody after or even after the stream is over. So I'll just be making sure to hit share and then you'll all have access to it. All right. So again, this is pretty quick and dirty as far as machine or AI algorithms go, right? Because this is going to be something that's actually generating a picture of something we ask it to generate an image of. So it's obviously not going to be too short, but it is not a whole lot of lines of code as far as that goes. So we're going to actually choose the number of inference steps, and this we can go anywhere from 8 to 12. We can go, let's max it out. Inference steps, and let's just go with 12 here. And then for our base model, we're going to use Stability AI, Stable Diffusion. Let's do Stable Diffusion XL, and then base 1.0. And you all can actually Google this to actually see what this base model sort of looks like. So this is this base model right here, Stable Diffusion XL base 1.0. And this is basically allowing us to use a pre-made model. You can learn a little bit more about it over here, developed by Stability AI. But this sort of allows us to generate images by using this pre-made model instead of having to train our own from scratch, because that would take a very, very long time. So I can share the link to that as well. Oh, I'll just ask for that. Here you go. So that's sort of the link to that. And let's continue making this. And then we're also going to have our repository. So repo name equals, and again, I am using, this isn't all my code. This is taken from another source. So a lot of this is, let's see. And then the repo name, we're just going to use ByteDance. This is actually the company that owns TikTok, ByteDance/HyperSD. So they're doing a lot of work in machine learning and AI as well, because actually similar to the recommendation algorithm that I mentioned earlier for Netflix, there's a similar recommendation algorithm that's actually a lot more powerful that powers TikTok. So that's why you see everything that relates like a whole lot to you. You're like, wow, this is, something super personal, and you're not seeing something like everyone's I think it's called a For You page, or everyone's feed looks different, right? If you're scrolling down your feed, it'll look very different from the way somebody else's feed actually looks. And they're using this by just, actually just gathering insane amounts of data about you, how long you're watching each video for, what each video is about. Um, Also, things like your age, if you give them all that information, your age, where you're from, what your name is, all of that goes into sort of crafting the perfect feed for you that'll keep you basically keep you scrolling for as long as possible. That's what their main goal is. So it's interesting seeing how that works as well, and how TikTok is actually one of the biggest players in the machine learning space or the AI space. Okay, looks like no questions so far. And then let's see. So basically what this is doing is setting the name of the tensors and setting the device. And the device is CUDA, that's basically NVIDIA's graphic support. So you run that, make sure everything is correct, no issues. Okay, perfect. There's a bit of a cache that it's clearing out. It's good. And everything runs as expected, no errors thrown. That means we're doing pretty good so far. Now we're actually going to create the pipeline for the diffusion pipeline. So pipe equals diffusion pipeline, and then from pre-trained. And a lot of this is just being given to me by, I believe this is Gemini probably, because this is on Google Colab. So from pre-trained, we have the base model. We have the data type, which is float 16, that's correct. Our variant, and these, let's not use an auth token because I do not want to set up a, if we use the auth token, we basically would need to actually get a token from Hugging Face and then use that, connect that to this, which is more work than it's worth. So we're not going to do that right now. And then to device. And then we're actually going to want to load this up. Pipe.load waits, and this is where we're going to be using the Hugging Face hub download for repo name, and there we go. And pipe.fuse. Use LoRa, and then the scheduler is just being built from here. And let's make sure everything here works the way we expect it to. Okay, perfect. So over here you can see it's loading a bunch of basically the model over here, loading everything up, making sure everything works properly. So this will take a little bit of time, so we can actually see how much time it takes out here, over here. And it'll be interesting to actually compare this to when we're running this on the cloud GPU. Make sure there aren't any questions. So someone asked the line called plural and the name and why we need those. So the plural, this is basically just adding a plural, so making sure there's multiple, like of something. So step would be singular, otherwise plural adds ness, so it's steps. And this is just the name of the parameter that we're passing into the Hugging Face Hub download. So this is where we're actually downloading it from, because we're actually choosing the number of inference steps. So if we wanted to, we could actually just erase this entirely if we wanted to keep this at 12 and just put an S over here, and it would do the same thing. And yeah, there's no NVIDIA driver on my system, so that's why the CUDA won't work. I need to connect this to a GPU actually. So to actually connect this to a GPU, you'd go to runtime, change runtime type, and then you can see the hardware accelerator written over here. I would just switch that from CPU, which is what it's currently on, to a T4 GPU. And I can save that, and that should work. And now MediaPi is not found because did not run this. And yeah, I'll paste the code in the chat real quick. That did not paste the way I expected it to. Let me just share the link to this so you all have access to anyone with the link in view. So y'all should be able to actually be able to see this now and not edit it while I'm working on it, which I think is what we're going for. So this would be the link right here. And yeah, you're welcome. And Ashu, hopefully I answered your question as well about the plurals. Again, you can get rid of that. That's mostly just to make sure that you don't have like a single number of inference steps. This is mostly just for testing purposes to make sure, okay, how does it look with one inference test or inference step versus how it looks with like 12, for example. Okay, yeah, perfect. And it looks like this whole thing is loading. So you can see it actually loaded a lot quicker as well on the GPU. So this is actually an example of how the GPU is clearly superior to using a CPU, especially for machine learning or AI tasks, just because the way GPUs work is they're very optimized for sort of matrix calculations. And that's all of what machine learning and AI basically is, right? It's a lot of just matrix manipulation. So that's what GPUs are best at. That's why they work much better for these sort of tasks than just a CPU would. All right. And then we can actually go into actually creating the image and the prompt. So we've basically, once this whole thing finishes loading, that means we've basically finished everything we need to for this, right? We're just waiting for a little green check mark over here. And now that that's here, we can actually write our prompt. So let's do that. Prompt equals, and someone someone in the chat give me a prompt. I'll let you all do that. And Shrewd, I see that you just joined. I'll walk through the code right after I'm done finishing writing everything. But so yeah, we'll get to that pretty soon. But let's see. A prompt. What do you all want to see a picture of? Picture of the sky. Let's make it okay. A cat in a rainbow coat. A husky. Okay, we're getting some good good answers here. Okay, let's see. We could do say a photo of a husky and a cat, and what was it, wearing a rainbow coat. Okay, so we'll make this our prompt. This is going to be a very fun prompt actually. And then we can quickly write out the rest of our code. So we have our guidance set to scale about 5.0 because it needs to be floating. And then our actual time to 0.5. And this is just sort of how detailed we want our image to look like. And then we can actually do the whole image equals, and then Python. This should do a lot of autocomplete for me. Prompt to set the prompt to what we've already given it, the guidance scale to guidance, the number of inference steps to the number of inference, the ETA to the ETA, the generator to torch.generator, and then I think we've already set it to the device up here. So let's set it to device instead of CUDA, just so we can change that more easily. Dot manual seed, and then we can just throw in any random seed that we've given it, which would be, let's actually set that up here. Seed equals, and then a random integer of seed. Okay, I think this looks right. Dot images. Do we have an extra? Yes, we do. Okay, dot images. There we go. So this is just us actually creating or sending all the information for what we want our image to look like. And then we're just going to have to do media.show images, and this should output us a photo of a husky and a cat wearing a rainbow coat. All right, so let's test it out real quick. And we'll see how long this takes us. Okay, so it took about 1 second per step, and hopefully we'll get, there we go. There's our output. A photo of a husky and a cat wearing a rainbow coat. That is so awesome. Let's zoom out a little bit so we can see the whole thing. And that's it. So this is just sort of an example of an AI model actually running in the cloud. Again, Google Colab is technically considered the cloud. So we can actually play with our prompt a little bit too as well if we want. Let's do that. Do we have any other recommendations? Let's check in the chat. Try Schrodinger's cat. Okay, let's do that. Photo of we do Schrodinger's cat. I think that's how you spell Schrodinger's. I don't think it's possessive. Okay, a photo of Schrodinger's cat wearing a rainbow coat, and then let's see what we get. So Ashu is getting an error on Colab. There's no NVIDIA driver on the system. So what you can do for that is go to runtime. So at the very top, there's a tab called runtime. You're gonna wanna click on that, and then there is another tab underneath that called change runtime type. And this allows you to change your runtime from different Python versions if you're trying to use Python or R, and switch your hardware accelerator between a CPU, a TPU, or a GPU. So really up to you over here. That should fix that right there. And then again, remember to, if you do that, then it terminates your runtime. So you have to start from the very beginning. So pip install everything again, and then go down and everything else. All right. And actually, yeah, let's see what our output look like. This is our Schrodinger's cat in a rainbow coat. Not sure where it's representing the Schrodinger's cat part, but it is definitely a cat in a rainbow coat, which is really cute. So yeah, this took about, what is this, about 11 seconds, right? And something that's actually really cool or interesting to take a look at would also be how this model differs from like over here versus running it on something else. And one example of that I'm just going to be using this specific for this specifically is RunPod. So RunPod is technically a cloud platform. Let me share that real quick. There we go. So this is what I was using just because where I had a few credits in here that were left over from a hackathon. So this is a sort of a GPUs as a service where you're able to run AI models on their GPUs. And it takes care of a lot of the issues that we mentioned earlier in the first half of this in the first half of the stream, where you don't have to worry about having a bunch of really expensive hardware locally. And then once you've run your AI model, then you have nothing to do with it. This just allows you to run your AI model, and then it's much more accessible as well. So we can actually, so again, this does cost money. That is something that I want to say. It definitely costs money. You will have to put some some amount of money into this. Most GPUs do cost money just because the GPUs themselves, they have a very, very high upfront cost. And we can actually take a look at that. So if we see the pricing of this, we see like an H100 from NVIDIA costs about $3.29 an hour on secure cloud, or $269 on community cloud. So let's take like $3.29 for example. Even if you were to run a model that took like 10 or like 100 hours to load, for example, right? You're still not paying that much. You're still paying under like $1,000. Versus if we ended up actually searching up how much an H100 would be for, and we can actually do that. H100 PCIe price, and this is an example of an NVIDIA H100 Enterprise PCIe, and this is essentially the same thing. Don't know why it's making all those noises, but this is not a very cheap price tag, right? Spending about $30,000 on a single GPU, only for it to only last you as long as you need it to, in terms of when you're running the AI model, and doing absolutely nothing other than that, is an absurd amount of money to be spending on, a piece of hardware that will probably be obsolete in 5 to 10 years, right? So that's a lot of money right there that's going towards nothing really. So it's really important to see which one you actually do need. So usually you won't ever need to purchase one of these for yourself. I promise you, like even your most demanding games could probably run on like a 4090 at most. But yeah, you probably won't be needing to use an H100. Anyways, coming back to RunPod, this is sort of the H100 right here, and we can actually figure out what we're doing. We can actually use one of our GPUs. So I have an instance over here set up, right, for an IPYNB. This is just another notebook, and I can copy and paste everything I've just done over to this. So let me do that real quick, and then we can see how it runs differently. And let's actually not do quiet so we can see what's going on. Stop this and rerun. Okay. And then if we were to do this, then let's see how long this whole thing takes. In the meantime, we can just preload what we had going on earlier. And this took about, I think it's 11 seconds on the last one. Let's see how long it takes on this. Could go through it a little quicker. Hopefully it does. Otherwise, I'm just wasting money right now. But let's see if there's anything in here. All right, everyone doing okay in the chat? Getting some errors. Someone asked, isn't AWS or Azure Notebook better than Colab for ML? Yes, technically it is, but I think Google Colab has the easiest to use interface. So all you need to do is really just type in like research, what is it? collab.research.google.com or something, and it's super easy to use, right? It's really simple. Versus if you go into like AWS's or Azure's, you might get overwhelmed by all the different features and the different tools that they have available for you to use, which it's it's definitely a lot. So I think it might actually be easier to use Colab in this instance just for teaching purposes. And then if you want to run this on AWS, I believe it's called like AWS Notebooks. No, it's Azure Notebooks. I forget what AWS is called, but that is, again, that's fully up to you. It might be called Amazon SageMaker, I think is what it's called now. Let me confirm that. Amazon Sage. Yeah, okay. It is Amazon SageMaker. That's to build, train, and deploy ML models. And we can actually take a look at that too if you want. Let's do that real quick. So get started with SageMaker, and you can see that like immediately there's an overwhelming number of options going on over here. Let's say even if we're trying to do it very simply for a single user. Then we have all of these, there's a lot going on right now. And then click on one of this and it takes you to all these domain details. It's a whole lot to look at. So it is in general much easier to just use Google Colab just as a starting point. And then if you do have a much more advanced, understanding of AWS or of Azure, then by all means, you should go and use that. All right. Okay, everyone else doing all right so far? It's taking a very long time, actually. It just takes a minute to download everything. Probably doesn't have a very good internet connection wherever this is at. I think I can check the location of my run pod. It is in. So currently I'm using an RTX A4000, and this is just in the US. It just says it's in the US. It doesn't say where. Okay, this is now done. And then we have our photo of Schrodinger's cat wearing a rainbow coat. This is really moment of truth right here. And yeah, you can see this is absolutely ripping through it significantly faster than the other one. And now we have this cat right here, which is surprisingly similar actually to, I think, our other one, which, let me take a look at the other one we just built, which would mean that this is actually, okay, no, yeah, it is different. So I was trying to make sure it was non-deterministic, because if it was, that would have been that would have been strange as far as ML models go, or AI models go. So yeah, you can see the background on this new one is sort of brown, and I think the cat is on a couch here, versus if you looked at our previous one, then the cat was just sort of really zoomed in, and yeah, it was just a gray background. So that sort of proves the point that I was trying to make here, that it is obviously a lot quicker to use another GPU. And then if I ended up opting in for like an A100 or an H100, it would probably rip through it much, much faster. And honestly, while we're here, we might as well, right? Let's do that. Let me Uh-oh, I think my computer is about to crash. Please don't crash. Okay, good. So let's say I wanted to create a new pod. So this is me deploying a new GPU, and let's go with what's like a really powerful one. We're like, this is super overkill. We obviously don't need to do this at all. Let's go with like an H100, right? Um, with this template and start Jupyter Notebook just so we can do this and take this to wait for this thing to run. So this is just building up. And while we're waiting for that, we can sort of just play around a little bit more with the prompt over here. See, because again, this is running significantly faster than our Google Colab one. And we can see that once again, instead of Major League Hacking. I wonder what shows up if I type in MLH. This is going to be interesting. Again, absolutely ripping through it in just 4. And it looks like it's a baseball player that's the hacking into something, which I guess makes sense. Major leagues, it's like MLB is really big, and hacking. So Shu seems like they're getting an error due to the change in the code. Otherwise, this, I'm not sure. Let me take a look at what the error could be. So does your CKPT name look something like this with hyper SDXL, num inference, and then steps, and then steps dash? That does look correct. Make sure that your actual number of inference steps is more than 1, because again, if it is 1, then it would just be step. But if it's more than 1, then it would be steps. So currently the number of inference steps is plural. So we'd want to make sure that this is also plural. So this is what we get with MLH. Okay, awesome. So she said it works, so that's great. Okay, let's see if our new pod has finished being created. Okay, so I actually wanted to know what the difference was that was causing the error. So I'm assuming you mean the error if you add that step back, then you'd want to just erase this S right here. So from step, you would want to just, it says steps right now, you just want to erase this. And if you change this to 1, then you'll have a single inference step. And that should fix it right there. Or not. Let's see. Yeah, I'm assuming this is like sort of the issue that you're having, right? Let's okay, so it seems like there's a range actually over here. We have a number of inference steps can only be between 8 and 12. So let's try this. So if you have 8, then it should run fine. But in that case, it just defaults to steps all the time. But in the case that the number of inference steps would have been less than 8, then that would work. So again, that was more just for testing than anything else, but we have our number of inference steps. We can actually bring that back up. And we can change the ETA to 1 here as well. And we can see how that sort of changes. So again, you can just play around with the code over here, see what happens. I think it'd just be interesting to, mess around with this and experiment a little bit. But going back to the pods, let's see if we can connect a new Jupyter terminal. So right here, this right here is the H100. So this is like one of the most powerful GPUs you can get. So I've just connected to this, and we have a new Jupyter instance set up right here that is connected to that. So let's actually see how quickly this thing is going to rip through it, given that we have an H100. And then I'm just copy pasting everything. And then our last one is this right here. This is just going to take a minute to collect all the files. So is everyone able to get that working on their machines? I'm just looking at the chat right now. It's a little quiet, so I just want to make sure that everyone's able to get that up and running without any issues, any errors. I can see a DT. You got it working. Malik, I think you might have said, I remember you said, I think you also got it working. No, you said you had an error. Malik, were you able to get it working? Okay, and we'll just wait on this thing, finish it. And again, obviously RunPod isn't the only GPU provider. I know there was actually one called banana.dev that I used. I actually learned about them through a hackathon, which was interesting because they were giving out free credits. Unfortunately, I think they went out of business, so that was very sad. Let's see. I believe this is almost done loading. And as soon as this is ready, then we can actually see how much faster this is compared to this right here. This has been running. Okay, let's try running this again. Okay, so just took about 4 seconds. This was with a much higher ETA rate, and this is just sort of to figure out what the quality of the image is going to look like. So this is a much higher quality image, and you can see it actually has text, but oh, I am not sharing my screen. Okay, there we go. So we changed the ETA here from 0.5 to 1, and this ends up, giving us a much higher quality image. This looks something like a website actually, but you can see some really interesting things over here. Like it's not really good at letters, right? So it was able to spell hacking right, but I don't know what happened down here after that, right? And then again, I think it's like common knowledge that AI is really bad with fingers just because just the way it trains. But it's interesting to see that it got the Apple logo almost exactly right, which is and it defaulted to an Apple logo too instead of like any other laptop, which is a really interesting thing to take a look at. So it's really cool just experimenting with all these numbers. You can change the sort of seed, you can change the guidance, you can change anything you want, and it'll just be interesting to take a look at. And let's see. So here we have our H100. It looks like everything is almost done loading up. We're just waiting for this star to give us a number. And then we should be ready. Okay, we have some questions. What is the website we're deploying on? So these are being deployed. I mean, most of you are probably on Google Colab, and it's just a Colab notebook. So that's sort of just the website that you're on to sort of deploy these to the cloud. And another question is, can we create a front end for this? You could actually create a front end for it. It would be difficult to connect it to Google Colab just because I don't know how well they play with like Flask, for example, where you can have it interface with a front end or an actual front end. So you might have to actually use some either cloud compute where you'd have to buy it or some local compute, and it would be interesting to take a look at there. Malik, looks like you said you use Gemini and explain the code, so that is pretty good. And there's a link in there as well. You can click on that link and take a look at what every line is doing line by line, and that'll give you a much more detailed explanation of sort of what's going on and why everything is working the way it's working. Let's see. This is still not done running. So we're just waiting on this one cell to finish running. And once it is done running, then we can move on. Don't know where I got stuck at. Let's try rerunning it. All right. Looks like everyone's doing okay so far. And let's see, this is not the right page. There we go. Again, still waiting on this thing to finish running. It is taking a while. Not sure why. Take a look over here. CPU utilization is really high, but there's no GPU utilization. So let's see if we can use the GPU actually here instead, where our device is CUDA. It should work. Interesting that it's not. Let's actually check what our device is by adding another cell. And I believe it's like print device. Let's Google it real quick. It's torch.cuda is available. And then let's see if this works. Stop this execution. And this one also stops. Okay, so it is available. That's interesting then that it's not using the GPU at all. It's just going full on CPU utilization. Okay, we killed the CPU. Now let's see if this works, hopefully. And again, I was looking at this tab right here to see what the pod utilization looks like. And it looks like there's some GPU memory being used, but no GPU and CPU was being used earlier to right here, 100%, which not sure why that's going on. All right, let's take a look at the chat. We have DT said, I think Google Colab is faster comparing to these. Honestly, yeah, I think just has they have better coverage, which means they're able to actually pull things from, let's say, the internet much quicker. And all of this is actually coming from Hugging Face. So it does take a while to actually load all that up. But in terms of everything that you'd be doing on device, which is this part right here, once you've already loaded the model up, then that does execute much quicker. And then Ashu asked, can you go through the run pod deployment step? So run pod is more like this is, I'm just trying to show you all that this is an option that exists. You don't have to use run pod. You can use any other cloud GPU provider if you want. But really for run pod, if you did want to use it, it does cost money. They unfortunately do not have a free tier. So you just want to sort of sign up or sign in. I can just log in. And then after I've logged in, I'll get something that looks like this, where I'd want to actually deploy a GPU pod. So I just want to click on this, pick the GPU that I want, and it tells you sort of what the availability looks like and everything as well. You have all the information here. So you can hover over that, see which one works best for you. And then I selected an H100 actually for this right here, which is taking a ridiculously long amount of time because of I think it's um, low amount of CPU. So even though it's got 16 vCPU, which is strange, but then scroll down and I used this template right here, the runpod PyTorch 2.1, and you can just deploy on demand. And then it shows you how much it costs as well over here. Currently for me, I'd be paying what, $239 an hour, but if I decided, hey, I want to use this for like a full week straight, then I can get a discounted cost and so on and so forth. So Ashu, hopefully that answered your question. And I really just want this thing to finish loading, but it's not, which is very unfortunate. It's proving me wrong. Okay, we just run everything from the start. Yeah, this is very strange as far as an H100 goes, but again, once it's once it's finished loading, then it works much better. So we have like Google Gemini, for example. Not sure if it'll be able to figure out what this is doing, but again, it's going through this whole thing in about 4 seconds, and we can see that it outputs, I don't know, like a person looking thing versus if we were to actually use the same exact prompt on the Google Colab notebook, which I am trying to find. Here it is. On this notebook, if we were to replace this prompt with this, we can see there's a slight difference in the amount of time it actually takes to generate the image. And that's sort of where the sort of GPU compute power comes in. And we get something that looks like this, which is, again, because it is completely random seed, we're going to get something that looks slightly different. And we can, change the numbers, see how that differs in our output as well. So change the ETA to something a little bit higher, something lower, and we get something that looks different every time. So this is more higher quality. Then we can drop it down all the way to 0.1 for something slightly lower. All right. Any questions on that so far? I know we've been over a lot in the past couple of couple of hours, but think it's interesting to see how, I mean, you all were able to actually deploy your own model right here, right? It's on the cloud. You have full access to this using the Stable Diffusion model, and you're able to generate your own images now instead of having to use, another third-party app. You can now just do it straight from Google Colab or wherever else you'd want. So I think that's really cool. Okay, let's see questions. Am I on LinkedIn? Yeah, I am. You can my LinkedIn is just my first name, Abdullah Hassani. If you search up like Abdullah from MLH, that should pop up, but if it doesn't, it's Abdullah Hassani. First name and then Hassa and I. Okay, this H100 is taking an embarrassingly long amount of time right now. I'm like really trying to get it to work just to see how fast this goes, but I think it just completely froze on me. And it looks like I think it is probably at full capacity or full utilization right now too. Yeah. And then memory's slowly getting up there too, so it's strange how it's taking so long. Okay, great. Any other questions? All right, awesome. No other questions. So again, you all did an amazing job, right? We all made this sort of work together, and that's something really cool, right? Um, we went over the different we went over basically AI in the very beginning. It was very much from last Global Hack Week, right? A lot of that, a lot of review for people who come in a lot to these Global Hack Weeks. So you all were able to answer a lot of the questions, the different types of AI models, and then sort of cloud computing and how that relates to AI and why it might actually be useful to use the cloud in running AI models. And we saw an example of that in Google Colab right here. And we can actually see that if you do try running it locally, it might be a little bit slower just because the well, you may or may not have access to a GPU, right? So if you don't have access to a GPU, then it'll likely run slower, versus if you did have access to a GPU, it might run a little bit faster, but likely not as fast as the GPU that Google Colab allows you to access. And then you can even upgrade to an even better GPU using these other cloud provider platforms, such as RunPod, which may or may not work, as was demonstrated here. They can be a little bit finicky. So I need to go in and figure out why my H100 overkill GPU is not working for this very simple AI model. But this one worked right here, which I think was interesting. We were able to take a look at that. So um, yeah, hopefully you all learned something new, right? But you know, if not, I'll be on standby. Y'all can ask me questions. You can send me a private message on Discord. Again, it's just Abdullah from MLH on the MLH Discord, or I'll be hanging out. You can put a question in the Global Hack Week chat, and I'll do my best to answer it. All right. Let's see if we got any other questions. Can I send you a friend request on Discord? I actually don't really answer the friend requests on Discord usually because I don't know who is sending them most of the time. So you can connect with me on LinkedIn if you'd like, and we can talk on there. And Aditi said you didn't get the full code fully. Is it the case for everyone? So the code should be right here, and this should work perfectly fine. I did share this link in the chat. Let me share it one more time. Um, So this is the link to the code, and this should give you access to um, everything you're looking for. Got an AMD GPU. Has anyone had luck with ROCm plus PyTorch? Unfortunately, I have an Apple laptop. I have a MacBook, so I don't have to interface with the GPU too much, so I'm not too sure. But I do recommend you look at like Stack Overflow or Stack Exchange, I believe it's called. They have a lot of different communities that can help you out with this sort of very technical question. So I think that would be a good idea. It would be a good idea to go on one of those sort of community pages and just ask on those. Can I drop my LinkedIn? All right, let me plug my LinkedIn in the chat then. Okay, I just I plugged my LinkedIn in the chat. You can take a look at it, uh, and just make sure to say where I know you from. That way, I'm able to actually accept the request. Then we have another question from Shrewd. Can, if possible, can you please download the IPYNB file and share it in the Discord? I can upload it to GitHub most likely and share the link to the GitHub. But yeah, so I'll be able to do that for you as well. All right. You're welcome. Now we are still waiting on this thing to finish running, which is actually kind of ridiculous at this point. So let's go in and check what the difference is between these two. So this is at like 95% GPU memory utilization, but see what happens if we rerun this entire thing, because this one, we know it works. So let's go from the top and just run all cells and check what the pod usage looks like. So this right here is the pod usage, and I'm just comparing the top one, which is the H100, to this bottom one, which is our A4000, and see what the um, difference in this looks like. We can refresh the usage amounts right here as well. So this is very static. Interesting. Do I need to reload the page? And no, that had absolutely no effect on anything. Okay, very interesting. And this thing was able to run again. Run all cells. Okay, yeah, and this is running it from the top and absolutely ripping through this versus this is still not able to do anything. There's definitely something wrong with this. It should not be. Huh, yeah, that's a later problem. So we have a question. Didn't get the syntax meaning, so I'm gonna try Python. Some resources to understand how the syntax works. I would definitely recommend actually a lot of these AI tools, right? So ChatGPT or Gemini, for example, are really good tools for actually just explaining what code is doing. And if you really just don't understand what it's doing, you can just keep asking it follow-up questions. And it's almost like having your own sort of code tutor to help you out. I know GitHub Copilot is also really useful for that. If you install that as an extension on your like a Visual Studio Code or whichever your preferred IDE is, it's actually really useful. And you can actually go to hackp.ac/pack and get GitHub Copilot for free using the student developer pack. And I think that's a really great way of just being able to learn code, right? So you just ask what it's doing, you highlight a certain thing of code or a certain like line of code, you say what's going on over here, it'll explain everything to you. And if you do have follow-up questions, it will answer those as well. So that would definitely be one resource, but obviously just for starters, there are also older videos on YouTube for streams that MLH had, as well as just other YouTube videos in general that really just go into the very basic sort of Python 101 crash course. And those are very accessible, right? They're usually pretty interesting as well. And you can sort of follow along and do what they're doing as they're doing it. And then you'll slowly start to pick up on the syntax as well. And it's really useful as well to just map out this is sort of what um, map out what a Python syntax looks like to C++ because you are a C++ programmer, and also understand what Python is able to hide that C++ would normally not. So there's a lot of things that are abstracted or hidden away in Python, whereas C++ it's a lot more explicit in what's going on. So for example, like data types, you don't need to explicitly write out like a data type in Python, whereas in C++ you would have to. So I think that's one sort of big difference that is important to note. And then just really understanding the differences between the two programming languages is pretty useful. And then Shrewd also has another recommendation for Nicholas Renette on YouTube for basics. And then for digging deep, Andrew Ng is also a really good resource. Yeah. All right. My AI model is still not running. Okay. What we're gonna wait, this is a lot of GPU memory just increasingly being used too. So I'm very confused as to what's going on with this GPU, but we'll take a look at this later. Hopefully that answered all of your questions. That is, I would say, about it for the stream. We just went over everything we really needed to. So again, if there are any other outstanding questions, I'm here for you. I'll be active on the Discord. But other than that, thank you all so much for coming. Hopefully you all learned something new, and I will hopefully see you all in the next Global Hack Week stream. All right. Bye, y'all.